Hello and welcome to the lecture X-ray photoelectron spectroscopy, or it can also be called as electron spectroscopy for chemical analysis, ESCA. But mainly, mostly it is and widely it is called X-ray photoelectron spectroscopy, in short XPS. So in this lecture, let us see the introduction of XPS. So XPS, it is most heavily used electron spectroscopy for finding the elemental composition of any solid substrate that is from the surface to the depth of 10 nanometers. So within the 1 to 10 nanometer, the elemental composition of the substrate can be found using XPS. And so finding the elemental composition of solid surface that is from the in the depth of 1 to 10 nanometer, it is important for the surface chemistry. And XPS can detect all elements except hydrogen and helium. So basically, there are two reasons why it cannot detect hydrogen and helium. Firstly, the XPS it only is optimized for core electrons, whereas for hydrogen and helium, they only have a valence electron. There are no core electrons for hydrogen and helium. So for hydrogen, there is only one electron, 1s1, which is a valence electron, and for helium, 1s2, two valence electrons. So there is no core electrons for hydrogen and helium. So XPS works with only core electrons, hence it cannot detect hydrogen and helium. And also there is a second reason that is the photoelectron yield are below the XPS detection limit. When we work with this valence electron, the photoelectron yield will be low, which is lower than XPS detection limit. So what spectroscopy can be used for detecting hydrogen and helium? You may write in the comments after finding it what spectroscopy can detect hydrogen and helium and why it can detect if you find the reason. You may write that in the comments. So, so why the characterization of surface is important? Because here, especially XPS is being used for finding elemental composition of surface. So why we are going with surface? Because surface layer it is different from the underlying bulk material. So this difference could be of chemical composition uh, that is composition and or speciation. So here composition is nothing but what atoms are present, like whether iron, aluminium, lithium, likewise, what elements are present, that is composition. Whereas speciation is nothing but the chemical environment. For example, if we detect aluminium, the aluminium can exist in different forms, like as a um, as a alone aluminium, that is aluminium powder. If you say the aluminium that is not bonded to any atoms, so aluminum either it can exist as a individual element without bonding. That is one case, and it can also exist as alumina like Al2O3. So in that case, aluminum is bonded to oxygen. So speciation is nothing but finding whether, for example, aluminum is in the to it is bonded to which atoms, or whether it is not bonded to any atom, as in the case of aluminum. So so finding the speciation is also very important because the properties will change accordingly. So with the same example, if you look at aluminium and alumina, so aluminium powder, this is highly explosive when disposed in the oxidizing environment because it reacts with the oxygen. So it is highly reactive and explosive. That's why it is used um, So this it is used as a propellant, rocket propellant for the space. That is, it is mixed with ammonium perchlorate. And it is used as a rocket propellant. Whereas alumina Al2O3, it is inert, so the aluminium present in Al2O3 it won't react. So this much difference is coming with the same aluminium element based on the speciation. So finding the speciation is also crucial. There are also finding the structural differences also there, that is bond angles or bond lengths, and also both could be there. That is chemical composition and differences in bond angles or bond lengths. Now, the two reasons for surface layer physical properties of a solid surface varying from the underlying bulk or external forces and internal forces. So, in case of external forces, there are two external forces: adsorption and corrosion. Adsorption is nothing but the surface has the capability um, to attract molecules of gas or solutions with which they are in contact. So the solid surface, it is having an interface with gaseous phase. Also, it can also attract uh, liquid molecules. So actually, it is in contact with the environment. So adsorption is nothing but absorbing these molecules of gaseous or liquid. Whereas corrosion, it is a natural phenomenon of conversion of metal into a more stable chemical oxide. So these are the two reasons. These are the two external forces that are responsible for surface layer physical properties to be different from underlying bulk. And the internal forces. So these exist through surface free energy. So surface free energy, it is a surface tension of a solid which arises from the molecular interactions at the air-solid interface. Basically, these are introduced by the abrupt termination of any long-range atomic structure. So the beneath the surface there are atomic bonds, and on the surface atoms there is a abrupt termination. So there are no atoms above the surface layer. Due to this abrupt termination, um, this can induce such effects like elemental segregation and structural modification. So basically, surface free energy, it is the can be equal in magnitude to work that would be necessary to increase the surface area of a solid phase. So to understand how the surface with the neighboring layers of environment, the surface composition and speciation, these should be characterized. So based on the characterization, surface properties can be tailored. So when we characterize the surface layer, then we can modify it according to the requirement, according to the desirability. So when we characterize if it is not desirable, then we may modify it to meet the desirability. Now there are different based on these characterization surface properties. There it is required in these areas like adhesion research, automotive industry, biosciences, and electronics industry, energy industry, medical, metallurgy, and polymer research. So these are some of the main areas where surface characterization is important. So transmission electron microscopy, it is a as it is microscopy, it will reveal only the physical structure of the object. And to reveal the chemistry, we require spectroscopy. So basically, the difference between spectroscopy and microscopy is microscopy will reveal the physical structure of the object, whereas spectroscopy is something that will reveal the chemistry of, that is like elemental composition or speciation. So XPS could detect an element of interest that exists at an atomic percentage greater than 0.05. So basically, it's like a 5% is nothing but 1 in 20. So it's like 0.05%. And XPS reveals the chemical environment of the observed element, uh, that is speciation. So this is the introduction of X-ray photoelectron spectroscopy. Thanks for watching this video and please subscribe to get more videos.